Welcome to the lecture on operators. In this lecture, we are going to see what an operator is and what an operand is. We will also look at the different types of operators that is used in Python, and these are arithmetic, assignment, relational, logical and bitwise. We will also be looking at the precedence of operators and how to use them in an expression. So, let us see what operators and operands are. An operator is a special symbol that will help you carry out an assignment operation or some kind of a computation. The nature of the computation can be arithmetic or logical. Now, the value that the operator operates on is called an operand. So, let us take a small example here to illustrate what an operator and operand is. In this case, the plus symbol that you see, the plus sign, that is an operator. This operator denotes addition. So, you see two numbers before and after the operator. So, 2 and 3 in this case are called operands. So, let us look at arithmetic operators. Now, arithmetic operators are used to perform mathematical operations between any two operands. So, let us take an example to illustrate the use of arithmetic operators. Create two variables a and b with values 10 and 5. In the previous lectures, we have already seen how to create a variable. So, we are going to use the same procedure here. So, the first operator that we are going to look at is the addition operator. It is denoted by a plus symbol, and this is how an addition operation is carried out. If I want to add two variables, then I am just going to separate the variables with a plus symbol. In this case, a is 10, b is 5, so the resultant sum that you get is 15. The next operation is subtraction, denoted by a hyphen. I have the corresponding example here. So, in this case I am going to subtract a and b, and the output that I get here is 5. So, the next arithmetic operation that we are going to look at is the multiplication operation. It is denoted by an asterisk, and if you want to multiply two variables, separate the variables and insert an asterisk symbol. The product that you get in this example is 50, a is 10, b is 5 again. Now, 10 into 5 is 50, and that is the output that you get. The next operation is division, that is denoted by a forward slash. So, you separate the variables and insert a forward slash between them. What you get is basically the quotient. So, in this case 10 by 5 gives you a quotient of 2, which is the output here. So, the next operation is getting a remainder, and it is denoted by the percentage symbol. So, let us take the same example here. I am trying to get the remainder when I divide a and b, and you just separate the variables and insert the percentage symbol, and that returns the remainder. In this case, a is 10 and b is 5. So, 10 is divisible by 5, and hence I get a remainder of 0. The next operation is exponent, and it is denoted by double asterisk. So, let us say if I want to raise a variable to the power of another variable, then I am going to use this operation. So, let us say in this case I want to raise a to the power of b, then I just say a double asterisk b. So, in this case, since we have a as 10 and b as 5, I am just going to raise 10 to the power of 5, and the corresponding output that you get here is 1 lakh. So, let us look at the hierarchy of operators. Now, I have ordered the operators in the decreasing order of precedence. So, the first is parenthesis. So, parenthesis is not really an operator, but anything that is enclosed within parenthesis gets the topmost priority. So, therefore, I have included parenthesis also as an operation. Now, this is followed by exponential operations, and then division, multiplication, and addition and subtraction are given the same precedence. So, let us take an example here. In this case, I have the following expression. I have a equal to 7 minus 2 into 27 by 3 square plus 4. So, to avoid confusions, I am going to add bracket for this 27 by 3 square term. So, 27 is the numerator, the denominator is 3 square, and to denote 3 square I add a double asterisk here, and the entire term I am enclosing it within parenthesis. So, once you execute the command in your console, if you print the value of a, it should return 5. So, this is how you will use the operators in an expression. You can also try out this example. So, now let us look at assignment operators. So, an assignment operator is used to assign a value to a variable. So, the first assignment operator that we are going to look into is the equal to symbol. Now, this is the most commonly used assignment operation, and that is because whenever you want to create a variable, you want to assign a value to it. So, we have learned how to use this operator in our earlier lectures. So, what it basically does is that it will assign values from the right side operand to the left side operand. Now, the left side operand is the variable name and the right side operand is the value that is given to the variable. So, let us take an example in this case. I am retaining the same variable names a and b. I am assigning a value of 10 to a. In this case 10 is my right side operand and a is my left side operand. So, the same definition also holds good for b equal to 5. So, the next operator that we are going to look into is the plus equal to operator. So, what it basically does is that it first adds the right operand to the left operand and then it will store the result on the left side operand. Now, let us take the same variables a and b. Now, if I were to denote a plus equal to b, then this would translate to a equal to a plus b. I have indicated that within parenthesis here. So, whenever I give a plus equal to b, then I am saying a is equal to a plus b. So, the first operation that happens is the addition operation, which is a plus b. So, the value of a plus b gets stored in a, and hence you can see that the value of a gets updated to 15. A was earlier 10 and now the value gets updated to 15. The next operator is the minus equal to operator. So, this is also similar to the addition operator that we earlier saw. It basically subtracts the right operand from the left and it will store the result on the left side operand. Now, whenever I give a minus equal to b, then it translates to a equal to a minus b. Now, whenever I compute the difference, in this case I am getting a difference of 5 and that is what I am printing. So, asterisk operator will multiply the right operand from the left and will store the result on the left operand. Now, in this case again I am going to retain the same values of a and b. A is 10, b is 5, which means I am multiplying a and b first. So, a asterisk b will give me a product of 50. Now, whenever I print the value of a, it will give me the updated value, which is 50. Forward slash equal to means division. So, whenever I use this operator, I am going to divide the right operand from the left and store the value on the left operand. Now, in this case a forward slash equal to b translates to a equal to a forward slash b. Now, if you print the value of a, you can see that the value of 2 has been updated to 2 from 10. So, now let us see what relational or comparison operators are. A relational operator will test for a numerical equality or an inequality between two operands. The value that a relational operator returns is Boolean in nature, which means it will basically return true or false. Now, all the relational operators that we are going to look into have the same precedence, which means they all have the same priority. So, let us create two variables x and y. I am assigning a value of 5 to x and 7 to y. The first relational operation is the strictly less than operation. It is denoted by the angle operator with its tip towards the left. So, let us take an example and see how this operator works. Now, we already have the values for x and y. Now, I am just giving the relation x less than y. So, now what will happen is that it will check whether x is strictly less than y. In our case, yes, x is 5, y is 7. So, yes, 5 is strictly less than 7 and hence the output that you will see is true. The next operation is the less than equal to operation. It is denoted again with the angled operator with its tip towards the left followed by an equal to symbol. Now, let us take an example. Now, in this case I am trying to print the output for x less than equal to y. So, in this case we are checking if x is less than y or is x at least equal to y. So, these are the two conditions that we are going to check. So, x is of course not equal to y, but x is less than y. So, that condition is satisfied and hence the output that you get is true. So, similar to the strictly less than and less than equal to operator, you have the strictly greater than and greater than equal to operator. So, contrary to what a strictly less than operator does, in this case you are strictly checking whether x is greater than y. Of course, it is not and hence the output is false. For greater than equal to, you basically are checking whether x is greater than y or is x equal to y. So, both the conditions are false anyways, and hence the output that you get is also false. So, a strictly greater than operator is denoted by an angled operator with its tip to the right, and a greater than equal to operator is denoted by an angled operator with its tip to the right followed by an equal to symbol. The next operation is the equal to operation. It is denoted by a double equal to symbol. And what do we really check when we give double equal to? We check if the left hand side operand is it exactly equal to the right hand side operand. In this case, the value of x and y are 5 and 7 respectively, and I am checking if 5 is exactly equal to 7 or not. No, it is not, and hence the output is false. The next operation is not equal to. It is denoted by an exclamation followed by an equal to symbol. So, in this case, the output is going to be true as long as x is not equal to y. So, this operator is frequently used when you are iterating through a loop and you want to run the loop or you want to iterate through the loop as long as a certain condition is obeyed. So, you can use not equal to in that case. Now, as long as x is not equal to y, my output is always going to remain as true. So, the next set of operators are the logical operators. A logical operator is used when the operands are conditional statements. The output for logical operators are Boolean in nature, which means they return true or false. So, strictly from the point of view of Python, logical operators are designed to work only with scalars and Boolean values. So, if you want to compare two arrays, then a logical operator cannot be used. So, let us take the first logical operation, which is logical OR. It is denoted by the letters OR, both letters in lowercase. Now, let us take a small example here. I am retaining the same values for x and y. X is 5, y is 7. Now, if I give x is greater than y and enclose that within parenthesis followed by OR and then check for another condition, which is x less than y, I get an output that says true. Now, why does it happen? So, a logical OR is designed to give an output true when one of the statement is satisfied. In this case, x is greater than y is not satisfied, so it is a false, but however, x less than y, that statement is satisfied. So, this gives you an output which is true. So, the inputs to the OR operator is basically false and true. So, whenever you have a false and a true operand, then the resultant is always true. So, hence you are also getting an output which is true. The next is the logical AND, which is represented by the letters A and D, all letters again in lowercase. Let us take a small example here. I am taking the same expressions that I have considered above. Now, in this case, instead of OR, I am replacing them by AND. So, for the same conditions, I am getting a different output, and in this case, it is false. So, why does this happen? If you look at the conditional statements, the first is x greater than y. We know that this is a false statement, it gives you a Boolean value of false. The second conditional statement is x less than y. Now, this is true like I earlier said. So, the way a logical AND works is that whenever you have a false and a true condition as the operands, you will basically get a false output, and this is because logical AND expects you to satisfy both the conditions, and unless both these values are true, it will never return the output as true. So, even when you have false true or true false, the output is always false. So, the next logical operator is NOT, represented by the letter NOT, again in lowercase. So, NOT basically negates your statement. So, I have taken the example of x equal to y. Now, we know the value of x is 5, value of y is 7. Of course, both of them are not equal. Now, the output that you will get from this conditional statement is false. So, we are trying to negate false, which means not false. So, that gives you a result which is true. So, that is why you get the output as true. Now, another important point to note in logical operators is that whenever you are giving these conditional or relational statements, make sure that you enclose them within parenthesis, because if you are not going to do it, then you are likely to get an error. So, let us move on to bitwise operators. So, bitwise operators are used when the operands are integers. So, these integers are treated as a string of binary digits and are binary encoded. So, when you are going to use a bitwise operator on two integers which are binary coded, the operator is going to compare bit by bit of the binary code, and that is how the operator got its name bitwise. The other advantage of using a bitwise operator is that they can operate on conditional statements. Now, these conditional statements can compare scalar values or they can also compare arrays. Now, if you would like to compare arrays, you would be using a bitwise operator. We earlier saw that we cannot use logical operators to handle arrays, and this is where bitwise operators step in. So, throughout the course we are going to be looking into two bitwise operators. The first is bitwise OR, which is represented by a pipe, and the second operator is the bitwise AND, represented by an ampersand. So, create two variables x and y with values 5 and 7. Now, these are the binary codes for 5 and 7, and we are going to be using these variables for our example. So, 0 corresponds to false and 1 corresponds to true, and in a bitwise OR, the operator will copy bit by bit of the result if it is there in either of the operands, but in a bitwise AND, the operator will copy the bit only if it exists across both the operands. So, let us take an example and see what these two statements mean. Now, I am going to be illustrating a bitwise OR on integers. Now, I am using the bitwise OR operator, which is a pipe symbol between x and y. X and y are my operands. The output that you will be getting is 7. So, let us see how this output was achieved. So, I have created two arrays here. The cells in these arrays consist of the individual binary codes for 5 and 7, and I have color coded them for reference. So, the first two positions of both the binary codes is 0. So, both these serve as my input operands. Now, both these positions have 0, and hence the resultant will also contain 0. Now, let us take the second position. The second position also has 0 for both the binary codes, and hence my corresponding position in the resultant binary code is also going to be 0. I have highlighted the positions using circles to just show you which cells I am referring to. So, now you can also see that positions 3, 4 and 5 consist of zeros for both the binary codes. So, hence the corresponding positions of the resultant binary code will also contain 0. Another important point to note is that the sixth position of both the binary codes consists of 1. So, the binary code for 5 and the binary code for 7, in both of these codes the sixth position corresponds to 1, and hence in the resultant binary code I am copying 1 for the sixth position. Moving further, if you compare the seventh position for both these binary codes, you can see that for the binary code 5 the seventh position has 0, and for the binary code 7 the seventh position has 1. So, in this case there is a difference in values between both these operands. So, we are going to see how to fill in the corresponding position of the resultant binary code. So, since we are using an OR operator, when one of the condition is true, the resultant always becomes true. In this case, if you can recall, so like I earlier said, 0 corresponds to false and 1 corresponds to true. So, we have one true condition. So, the resultant will also contain the true value, which is 1. So, an OR operator will give you the output as true when one of the operands is true. Now, we are left with the last position, and for both these binary codes the last position is 1, and I am going to be copying this value to the corresponding position in my resultant binary code. So, this is the binary code that you get when you apply a bitwise OR between two integers. This is the binary code for 7 that we earlier started with, and this is how a bitwise OR operator works between two integers. We can also use bitwise operators for conditional statements. Now, if I were to use the bitwise OR for a relational statement, this is how it would look. So, I am giving two conditional statements here. The first is where I am checking if x is less than y. The second is where I am checking if x is equal to y. Now, in this case x is less than y, that results in a value which is true, and whereas the second conditional statements, which is x equal to y, will result in false. In this case the first condition is true, and hence the output that you get is also true. So, now let us look at the precedence of operators. I have ordered the operators in the decreasing order of precedence. So, like I earlier mentioned, parenthesis is not an operator. Now, any expression with operators that are enclosed within parenthesis, they get the topmost priority. So, that is why parentheses always occupy the first line in terms of precedence. Now, after parenthesis, I have the exponential operation followed by division, multiplication, addition and subtraction are given the same precedence. I then follow it up with my bitwise AND, bitwise OR. All relational operators are given the same precedence, and then comes the logical NOT, logical and logical OR. So, this is the decreasing order of precedence for all the operators put together. So, to summarize, in this lecture, we saw what are the important operators. We looked at what arithmetic, assignment, relational, logical and bitwise operators do. We also took an example in each of these cases to illustrate how the operator works and what is the nature of the output. Thank you.